Okay, welcome back. Last time we have already discussed how to build the first time series predictor. Today, I would like to show you my first automated valuation model, AVM, which can be considered as a cross-section estimate of house price by giving housing attributes information. The screen shows you my Google Colab, and here the program is my first AVM. So it's a very simple program with just about 12 routines. The first one is to install Scikit-Learn. You click run. And then the second routine is to import those library, including NumPy, Panda, Seaborn, and Sklearn. So these are very powerful libraries and tools for linear algebra, visualization and data plotting, data manipulation and analysis. And Sklearn is the focus of this video. It's a library in Python for machine learning and optimization. And today, I am going to import its train test split algorithm and the linear regression algorithm. Then the third routine is going to demonstrate how to retrieve a CSV file from a Google Drive. Last time we showed you how to get data from a website or from a URL. And this time I would also like to show you how to save a CSV file in Google Drive and then make use of this simple routine to retrieve data from your Google Colab notebook drive. So on the left top corner, if you click File, Locate in Drive, then it will switch to your Google Drive, and provided that you have already saved a CSV file. Say, for example, I have already saved a Auckland housing prices 2017.csv data file in the Google Drive, My Drive, Colab Notebooks directory. Then I simply provide this from Google.Colab import drive and drive mount, and then specifying the CSV file name and define data as the pd.read underscore CSV. Let's click. Then it will ask you to enter your authorization code. It's because of the security issue that Google would provide you this URL, which will require you to log in and get the authorization. Okay, so then coming back, you click Control V to paste the authorization code. Then Google will allow and read the CSV data file and show the first 5 records. Here, say for example, the first row shows you this house of 1 bedroom, 1 bathroom, 23 square meters building area, freehold land, was built in the 1990s, and the house was transacted in September 2017, and the transact price was 205,500 New Zealand dollars. So, okay, so we have about 1,400 records. Then the next routine is simply providing more details about the summary description of the data set. As here you will find the 24 columns of variables or attributes, and then this table shows you the number of counts and then their mean. Say for example, in this sample, the average number of bedroom is 1.59, and standard deviation about 0.7, and the maximum number of bedrooms is 5. Okay, so now we have already retrieved the data set. Then let's plot a scatter plot. of each attribute with price to see whether they are in positive or negative correlation. Yeah, so it will plot one by one. And since, say, for example, the building floor area is a continuous variable, and here you will find that they are of a positive correlation, which is as expected. As bigger the house, higher the price. And they showed that most of the houses transacted was smaller than 150 square meter. And then for number of bedrooms, you would also find a slightly positive correlation between the number of bedrooms and housing price. Okay, these are the scatter plot. Someone may prefer to plot a heat map of all the coefficients, correlation coefficients, instead of this chart one by one. So we import the SNS, the Seaborn, which provide a library to plot heat map, and you can define the color code and also define the correlation as data dot CORR bracket and then plot. So here shows the result. Say, for example, bedroom and price would have a positive 0.44, 44% correlation. Price and bedroom, positive 44%. Price and bathroom, 19%. Price and building area, 74%, etc. Okay, now after heat map, of course, you can also ask the exact correlation coefficient by using this data dot correlation function, and which will show each pair one by one. Then after showing all these correlation, now it's time for us to build a simple AVM. So it's very simple. First of all, we define X to be a group of attributes. So it means all the data by dropping the price column. And then we define Y to be the price. Now we define and split the data set into two portions. 10% here, 0.1, implies that we define 10% of the data randomly to be the test data. So the X test and the Y test would be 10% of the data set allocated randomly. And then the remaining 90% would be the training set, the X trained and the Y trained. Okay, so we split the data into two sets. After that, we use this linear regression algorithm to fit the training XY. Okay, after that, let's see how good the result is by reporting the predicted Y, predicted price of these X attributes in the testing set, and report the explanatory power by the R square and the mean square error. So it shows that the explanatory power is about 81.5%. It's not bad. Then let's show the difference between the actual and the predicted in two decimal places. Yeah. So say, for example, when the actual transaction price was $207,000, but the predicted one is $302,995. Then we can also use a scatter plot to compare the actual and the predicted. Yeah, here's the chart, shows you the actual and the predicted. So it seems like to be a 45-degree straight line. So that's the reason why the R square is about 8. Okay, Then now after training and testing, the models, AVM model seems to be performing quite good. So let's make a new prediction or estimation by feeding in number of bedroom, bathrooms, building floor area, freehold or leasehold, right? The cohort, the year of completion, and the transaction month. Now here, what I define an R rate of new data for this X new, which stands for a set of housing attributes of 2 bedroom, 1 bathroom, 78 square meters for area, freehold interest, and also transacted in June 2017. And we define the estimate Y new to be the predicted of this X new R rate of attributes. Let's see. Okay, it's about $814,000, right? 2 bedroom, 1 bathroom, 78 square meter, and the actual transaction price was 755,000, right? Seems to be quite close, not bad. And the last two routines are supplementary information. For example, you can also report the intercept and the coefficients for each attribute one by one. Right here shows you the estimated coefficient. And then, right, is a linear regression machine learning algorithm. Here, I also make use of the stacks models to show the statistical linear regression results for you to compare. And here shows you that statistical linear regression, the R square is about 71%, and right, the bedroom, bathroom, and building areas coefficients and p-values are shown here for reference. That's all for today.